afternoon, everyone. My name is Stuart Crawford, and welcome to our monthly LA Networks webinar. I'd like to thank you for taking the time out of your lunchtime to come and join us today and learn about introduction to networking in AWS with our very own Jason Bomar, who is one of our chief network architect at LA Networks. And before we get started, just some housekeeping for us all. We will be fielding questions throughout today's webinar, so feel free to use the question pane found within the GoToWebinar control panel. Ask your questions there, and we'll rally up all the questions near the end, and we'll have a question and answer period for you all after Jason's presentation has completed. We will be recording today's call as well, and it will be available online early next week through the LA Networks website. Watch for the URL in an email or on your favorite social media channels post conclusion of today's broadcast. Okay, let's get started. So I'm going to flip it over to Jason, and Jason gets started with his presentation. And it's a good one, too, on introduction to networking in AWS. Take it away, Jason.
Thanks, everyone, for joining. I really do appreciate it. We'll be going through a high-level introduction to networking in AWS. For those of you who don't know me, I am Jason Bomar. I'm the Chief Network Architect at LA Networks. I also run the Cisco user group, so there's a lot of you, I think, who are probably attending from the Cisco user group. Feel free to reach out to Stuart or myself if you have any questions regarding any of those. So real quick on the agenda, we'll go through some common misconceptions, and this is really cloud general, not AWS specific. And these are misconceptions I run across all the time with different accounts, and I spend a lot of time these days working with customers when it comes to connecting to clouds. And a lot of it starts out as connectivity to a cloud and then evolves or morphs into some of the networking best practices within a cloud. So we'll talk about some of the common misconceptions. Then we'll get into AWS specific items, like just some of the common items. They're not necessarily networking centric, but they're the items that probably are driving your company or companies to look at adopting a cloud approach to certain aspects of their business, right? No one's going to the cloud because they want to manage fewer routers or something like that. They're going there for maybe, compute capabilities or improvement in storage capabilities or something along those lines. So we'll talk about at a high level some of those common items just so you're aware of them. Then we'll go into the networking basics, and then we'll look at networking connectivity specifically. And then we'll wrap up really with just a list of recommendations and pitfalls. Anything that has led me to lose sleep, I'll try to document here so that you don't have to lose the same sleep I did. So, and then when we post the slides, there'll be some links as well that you'll want to take advantage of if you're interested in kind of furthering this journey a little bit. So they go through a number of deeper dive sessions and trainings and so forth. So let's go ahead and get started. So some common misconceptions, and again, I run across these all the time. In fact, I was working with a client last week in Florida, and a lot of these came up. So when I say they're common, I run into them all the time. And some of them are completely, against one another. And the first one is that cloud is either way more expensive or way less expensive. And I find in general, when I get two competing viewpoints when it comes to cloud, it's almost always because it's actually a complicated situation. So probably the best way to put it is that cloud is less expensive in some situations and more expensive in other situations. And there's a lot of gray area in there as well, soft savings in terms of if I can do something much faster in the cloud than I can on-prem, how do I quantify how much that might have saved me? How much did that cost, let's say, if it took a lot longer to do something? And usually when it comes to speed of deployment, a lot of it has to do with if the infrastructure needs to be ordered net new, right? There's obviously, you gotta have time to cut a PO, get it configured, get it racked, cabled, powered, all that. And that obviously is not an instant thing, whereas in the cloud it is. So that's where some of the largest time savings are. What I find is it'll be less expensive for certain development efforts, especially if your organization is doing a more agile approach to its development cycles. You'll find that it might be significantly less expensive. I find that if you're going to run production up in a cloud, it's probably going to be more expensive in the long run. You sure might pay a lot less up front, but as that monthly recurring bill comes in, it does add up. Now, you might get a lot of soft dollar savings there. So that's why I say it's actually kind of complicated as to whether or not it's more or less expensive. The most important thing to do is to take the time to do your research for your particular company and how they intend to use any cloud. And this goes for any cloud, not just AWS. Second one is cloud is not secure. I take a lot of heat over this one, but I would say it has the potential to be as secure or as insecure as any on-prem data center. Amazon does a very good job of securing their end of things in the cloud environment, as do other cloud providers like Azure or Google Cloud Platform. However, there's also a due diligence on your side. You're not natively secure or insecure, I think, by nature of being in a cloud. If you put a firewall-like policy in place that's a permit IP, regardless of whether you do that in a cloud or you do that on-prem, you're going to have problems, right? So I tend to fall on the cloud can be as secure or as unsecure as you desire to make it. Now, there might be certain specific industries that have certain specific requirements that make it difficult to move to the cloud, and that's fine. Not every workload is really meant to go to the cloud. However, I wouldn't let security in general hold me back from taking a look at cloud adoption. Not to say that it isn't a key item, it is. However, I think you just need to have the conversation with a cloud provider on what their best practices are, what their capabilities are. Talk to some of your vendors. Most vendors these days have equivalents of their products up in the cloud marketplace. I can go to the AWS marketplace and still order, my Firepower firewall, for example, right? There's a lot of security options up in the cloud. The next one, and I don't get this from IT workers as much, but I hear this when I'm working with business units, and this came up just last week. You don't really need to know anything about IT to work in the cloud. It's just magic. It just happens. And that might be true in that I can run a credit card and get an AWS account set up and, spin up a Linux box or something like that and just start working right away. And I don't really know anything about everything I just did. However, the second you want to go a little bit further than just that, I want to now set up an entire data center like infrastructure in the cloud. You're going to find you need to know a lot about IT. So I see this an awful lot. Sometimes businesses, saying like, well, IT moves too slow for me, so I went to the cloud because it's very fast. And then I ran into some problem, but my IT staff couldn't figure it out. Well, you didn't really bring the IT staff in at the beginning, and that makes it very difficult. I try to counsel most of my clients and customers. You need to be proactive in talking to your business about some things that might be painful for them about how you've done IT in the past and what you're going to do about that in the future, and start to understand where those gains and pain points, can kind of line up, right? Cloud works for that in some regards, and it does not work for that in other regards. And it's a little different for every company, but that's a critical conversation you want to have up front. And then I also get, again, competing views here. Cloud is more reliable or it's less reliable than traditional infrastructure. And again, it's complicated. When it comes to AWS in general, they have very high SLAs, but they write those SLAs in very specific ways. So you do need to be careful that you're reading the fine print on those. And again, if you build an app that's poorly built with no resiliency in the app itself, is that really Amazon's fault? If they patch a system and your whole app goes down, right? You should have been thinking ahead of time from an application perspective, how am I going to build some resiliency in, right? And so it's just a complicated question again with a lot of nuance just depending on your particular environment. Hopefully that helps set at least some ease on some of the misconceptions I see the most often. And if you have other ones, you can let us know. And if we can't get to all the questions during this session, just reach out to us and we can schedule a follow-up. We'd be happy to do that. So let's talk about some of the common items. And the first one is, in a way, the most critical, and it's regions and availability zones. And I'll call availability zones AZs from now on. So currently there's, I believe, about 18 regions in AWS. And a region's just a geographic location for AWS to have a data center effectively. There are other things called edges I'm not going to go over in here for their content delivery network. However, when it comes to if you actually want to put infrastructure into a cloud, it needs to go into one of these regions. Now, I will say this, Amazon spins up regions somewhat frequently. It's not uncommon to see a few come up every year. I believe that France came up earlier this year, And I think that they have a few others coming up this year as well. I expect they'll probably be at close to 20 by the time they get to reInvent in November, for example. So this gives you an idea of what their global footprint looks like right now at this moment. Now, an availability zone, or an AZ, this is basically a highly independent infrastructure cluster within a specific region. So if these are my regions, and if up here in kind of the upper left, I have an Oregon region, for example, and it has 3 availability zones, they'll look like a cluster of 3 campuses or buildings somewhere in Oregon. So the best way to think of an AZ is just a cluster of data centers, right? And each AZ could be a single building or it could be a few buildings. But what you'll find is between the different AZs, they're highly independent of one another. So separate power, separate fiber paths, separate telco services, all sorts of things like that. So that if any AZ goes down, the region is still fully functioning, with the exception of if there was any resources that were in a single AZ, right? A couple of things to note on AZs is there's, generally speaking, very low latency between the different AZs in Amazon. So I'd say, between 1 and 4 milliseconds. In fact, I don't think I've ever even seen one quite as high as 4 milliseconds. Like in Oregon, I spent a lot of time working in Oregon, for example, and between 2 of the AZs, you can usually expect 1 to 2 milliseconds, and between those 2 and the third, I notice it's usually 2 to 3 milliseconds. We don't know exactly where the AZs are located within Oregon, but you can kind of imagine that they're somewhat close together to get those sorts of latencies. We talked a little bit earlier about resiliency within your apps, and AZs play very tight into certain types of resiliency. And this is, again, one of those nuanced questions. We won't deep dive into it, but you need to understand your applications and how they best are resilient. Can they handle, each of these AZs, by the way, is a more or less a layer 3 boundary. So your subnets are going to span into different AZs. So if you can't handle a layer 3 failover, for example, then you probably don't want to try to do a cluster across AZs. You might want to take a different approach with some snapshots and some automation templates to spin up some. So it's just one of those things to look at. But regions and AZs are kind of the top level item from AWS that you want to start with when you're looking at where you're going to be networking, because when we come back to these regions, you need to fall in one of these regions from the perspective of where to put your infrastructure. Now, your application might be reachable from a lot more locations because they have this concept of edge locations if you subscribe to their CDN network. Your actual infrastructure needs to go into one of these regions, right? Let's talk about some of the reasons that drive people towards the cloud in the first place. And one of the really basic ones is EC2, or their basically compute unit. It stands for Elastic Compute Cloud. And one thing to be aware, so this is basically their VMs, their systems, right? And one thing to be aware of is many of the services in AWS are also just in EC2 under the covers. So if you're already familiar with AWS, things like your Elastic Load Balancer or your virtual gateways, which we'll talk about in a little bit, those are actually clusters of EC2s. They don't look like that to us, but I was on a call recently for troubleshooting a VGW, and he was explaining, yeah, it's a bunch of EC2s under the hood. Just be aware that most of the items you work with up in AWS will be EC2s. Now, one of the reasons people like, some businesses really like the cloud computing perspective is all the flexibility on how they can gain ways to buy their compute cycles. And let's take a look at some of those. So in Amazon, we have 4 main ones, and that's on-demand, reserved, spot, and dedicated. So on-demand is the default, and effectively, if you just want a resource for a short amount of time, on Linux you pay, I believe, by the second, Windows I believe you pay by the hour, but you have no commitment on the term, then you just get an on-demand. A lot of times when I'm troubleshooting in AWS, I might spin up what they call as a micro on-demand instance, which is often free, no charge. And I just put a IP stack on it and I can use it for tracing and pings and things like that. And I might only leave it up for a half hour and tear it back down. And if it's a low-end instance, I didn't even receive a charge for it. If you know that you're going to have some production, and so I see on-demand happens a lot with dev, for example. They don't need the resources for a very long time, and it's very quick. They can just pick them up and go. The next one is reserved. Now, you'll save a lot of money per hour on the reserve, but with the reserved instance, you pick the type of server, then you pick a commitment term anywhere from 1 to 3 years and how you want to pay that. and you get a big per hour reduction from the on-demand pricing, right? However, now you're locked into a term. So I see reserved instances. Most of my customers use those for their prod apps that move into AWS. Then they have a nice predictable model. And by the way, through all these cloud providers, you can do a nice chargeback model for exactly who consumes what. There's caveats and you got to think through it. It's not automatic, but it is kind of nice if you can say like, well, I know that business unit A had, 30 different reserved instances of this type, and here's their bill for those 30 instances, and you could just pass it along to business unit A. Spot computing, I think of it as eBay for compute. Basically, you can effectively bid on what you're willing to pay for resources when it comes to compute. So you may not have a lot of flexibility, but you can buy a lot of compute resources for short amounts of time to do large parallel processing. The poster child for this particular one would be genomics research. Amazon has a pretty famous business case where they were working with a company that was doing some genomics research, and a particular job that they would run on-prem, which took a long time, and they had to spend a lot of money to get the compute resources allocated for it. They were able to do it through Spot for like 1/100th the cost and in just a few hours as opposed to a few weeks. And so Spot instances, I don't see a lot of people using Spot, but it's a very nice way to go if you have a job that has some flexibility and you don't need the resources for a long term. And you can save a lot of money on Spot instances, because effectively what Amazon does is says, when we have a lot of CPU cycles that are available because some people have spun down their on-demands or something, maybe it's off hours or something for your region, you may find that the price drops really low. It hits your buy point and you spin up your 1,000 instances and run your giant, massive parallel job. Last one is dedicated hosts, and I don't really seem to run in much to dedicated hosts, but according to Amazon, the main use here is when you need dedicated hardware for some reason. Usually it's to avoid multi-tenancy, perhaps because you're in a highly regulated industry. It can also help with some licensing for certain solutions such as Oracle. I don't know of a customer yet who's had a requirement for dedicated hosts. However, those are the two use cases that seem to come up the most commonly. So obviously Amazon sees them. I see a lot of times the on-demands and the reserved. I see the dev folks usually using on-demand and the prod folks usually using reserved. This chart's a bit of an eyesore, but I just want you to be aware these are all the different instance types that you can utilize up in Amazon, and they have a different speciality. So for example, if you're doing a SAP HANA install, you want the X1 instance, right? That's memory optimized for something like SAP HANA, right? T2 is the one that I see the most for on-demand instances. So this is their lowest cost, and it's just a general purpose, right? So again, I use T2, what they call a T2 micro a lot of times, simply for spinning up a Linux box for me to maybe ping or trace from to other resources and make sure I have my connectivity. So I'm not going to spend a lot of time, but just be aware you have all these different families, and then each family will have different instance types within it. So I mentioned earlier T2 micro. That just means a micro-sized instance, minimum RAM, minimum disk, and so forth, right? Minimum compute, in the T2 family. The letter is what really tells you the family. The number is really what generation that they're on, right? So T2 would just mean the second generation of the T family. The next one is Identity Access Management, or IAM. The big thing here is to just be aware no one in your company can log in to AWS until they have an account in IAM, okay? And we talked earlier about the regions and the AZs. There are a few services, and IAM is one of them, that are actually global services, meaning IAM does not reside in any given region. Rather, it's global and it affects all regions. So you don't have to set up things like accounts and permissions per region. So if you're currently in US West 2, that's in Oregon, and you're going to spin up something in Virginia, which is US East 1, you don't need to go recopy all the accounts and everything in IAM, because IAM is a global service and it's reachable from any region. For those of us that are more Cisco savvy, this is very similar approach to RBAC, or role-based access control. You're really setting up users and roles. Be aware that if you create a user and you assign them a password, but you don't give them a role, then they will have no permissions and they can't really do anything. So you really need to do all those different steps. Also be aware that once you've created an account, by default, that user, assuming you've created it properly, that user can access, console, CLI, API from pretty much anywhere, right? So if you want that locked down in some way, shape, or form, you need to be sure to consider that when you're setting up your IAM. IAM also supports multi-factor authentication, so you can, and I'd probably recommend something along those lines, so you can use it with an MFA solution. And just as another reminder, if you create them an account but don't assign them to a role, they won't be able to do anything. First time I was playing around with IAM, I was exactly what happened was I created an account and then they couldn't do anything. I forgot to put them in a role. Another global service is S3. This is just a storage service. It stands for Simple Storage Service. That's what S3 stands for. This is object-based storage, so it's not storage for your OS. If you want block level storage to install an OS on, you're looking at something called EBS or Elastic Block Storage, which is tied to the EC2 service. S3 is a global storage service. It's an object-based storage solution. So you effectively store objects in these items called buckets, and you can define permissions on your buckets. And the first best practice here, you need to be very careful on your permissions to never open that S3 bucket to the public unless you really want whatever's in there to be publicly reachable. It's fine to open it to the public if you have content in there that needs to go to the public. However, you need to be very careful that if you have your company's personal information in there, that you never ever allow that S3 bucket to be open to the public, because you will find anyone can read or write once you do that, okay? S3 is, again, it's a global service. It's not in a given region, and it's a public service. It's on the internet backbone for Amazon, and that's why you never want to open up the public side unless you actually mean to. Now, S3 comes in 3 different flavors. There's just standard S3. There's S3 infrequent access, and then there's S3 one zone infrequent access. S3 is the default. If you want to save some money, you can go in infrequent access, which effectively just means you'll get not as good performance. It's not what you want to, you don't want to store information in IA if you need access to it all the time. However, if you don't need instant access and fast access to the information in S3, you can save significant money by moving it into IA. It's not an archiving solution. They have a different solution called Glacier, which is very cost effective for archiving, but has even poorer performance. It takes 3 to 5 hours to retrieve something from Glacier. And then the 1Z IA is kind of recent. I can't remember the old name for it. It's a service that was relaunched recently as 1Z IA. It's infrequent access, but only in a single availability zone. So in S3, I believe that their SLA is 11 nines for data loss. And in S3 1Z, I believe it's 3 nines, or maybe 3 nines and a 5. I can't recall right off the top of my head, but effectively you give up some reliability to save even more money effectively, right? And remember, if it has the infrequent access, that means it's not going to be the high performance storage that you might necessarily want, right? One other quick thing is you can turn on versioning. You can even do cross-region versioning in S3, but be very careful when you turn on versioning in S3, because there's no way to really turn it off again. You can kind of suspend it, but you can't turn it off. If you have items that are very large and updated very frequently, you almost never want to turn on versioning. It would be better to do something like snapshotting or something like that perhaps, but not versioning, because it will keep, if I have a large, 5 terabyte database or something, and it's getting hit all the time and I've got versioning, I'm going to keep so many versions, you're going to find your S3 bill goes through the roof. So just be aware of that. You don't want to turn on versioning for something that's large and changes frequently in AWS, unless you really truly have a reason to do so, and then by all means go ahead. So now we'll hop into the network basics. And again, I cover those other basics because those are the items you're going to be networking to and from, and those are the reasons that your company might be looking at a cloud provider like AWS, right? So I just want to give you enough of an overview of those so that when you're in a meeting and they start talking about, and there's a million more services, I just touched the most common ones. However, that way when you're in there, you have some way to frame up that conversation and understand what they're looking at. So the basic unit in networking in AWS is the VPC, which just stands for Virtual Private Cloud. And when you create an account in IAM, it actually creates you a default VPC in every region. So you may not use that default VPC. You could never use it if you didn't have a need to, but it does create one for you. Basically, think of it as your private data center in the cloud. And when I say your, I mean it's actually yours. It is by default, it's more or less self-contained. There's no way in, no way out, more or less, until you start to build ways in and out, because you're eventually going to want to connect the things in there, right? The VPC is a region-based construct, so please remember that. And also please remember it's tied to your IAM. So right now there's a limit of one account for the VPC. So when I say it's a region-based construct, what I mean is if I build out a VPC in Oregon and I wanted to extend that into, say, Virginia, I cannot do that. I'd have to build out a separate VPC in Virginia. Now, I might be able to connect the two. I could build a VPN tunnel or something between the two, but the VPC itself is region specific, okay? And you might think that's not a big deal. It actually, depending on your apps and your company, it can be a severe restriction until you truly understand it. And then there's a lot of ways to work your way around it. You know, could be through VPNs, SD-WAN's a common one to do as well. So, and while it's common to use the default VPC in a region, because like I said, when you create your account, it actually auto creates for that account a VPC in every region. You should never delete the default. And I was told by an Amazon architect, actually, he recommended not using the default anything within a VPC. And he said it's just because, think of it as VLAN 1 on a switch, is how he told me. He said, you know, the default objects tend to have some special significance that if you don't have a reason to use them, you should probably avoid it and just create net new. And there are limits to how many VPCs an account can have in a region. However, I don't know what that scalability limit is, but I don't think it's super low. You probably wouldn't build out a lot of them for a single account. There are designs where you want a lot of VPCs, but that's usually because you also want a lot of accounts to go with them. And I'll actually be talking about that at Cisco Live. So if anyone's going to Cisco Live this year, please reach out to me, and I can, you know, if you can't get into the session, I'd be happy to share the slide deck or anything with you. So the VPC, by the way, contains a CIDR block, and then you break that CIDR block down into subnets, and each subnet is attached to a particular AZ or availability zone. And so when I talk about the VPC as kind of the base network unit, this is exactly what I mean. You create a VPC, or you could use the default one. But let's say you create one, then the first thing you do when you create it is you assign it a CIDR block. Maybe it's, you know, 10.1.0.0/16. And then I can create subnets within that CIDR block. I could say, you know, 10.1.1.0/24 and assign that to AZA in Oregon. And maybe 10.1.2.0/24 and assign that to AZB in Oregon in that VPC. So the VPC is a regional construct that spans AZs. It's effectively in every AZ within the region. And lastly, there is such a thing as a VPC router, but you only have a small ability to interact with it. You can view its routing table and you can add static routes, but that's about all you can do with the VPC routing table. So for example, when you add in a CIDR block to your VPC, it's going to be added into the routing table for the VPC no matter what you do. You can't say don't put this in the routing table. It's in there no matter what. This is kind of what a VPC looks like, and I'm using, to the best of my knowledge, AWS's specific icons here, but they tend to think of the VPC as this kind of rectangular object. The availability zones are usually what bifurcate the VPC, even though the AZ is more of a regional construct. Each subnet goes into a specific AZ, and so there's a portion of that AZ that runs through that VPC. So you can kind of see, here's our master subnet or CIDR block, 172.16.0.0/16. And then here are my 2 subnets, and I've created those and put those in unique AZs. So if you wanted to deploy an app that was highly resilient and it was able to handle things like a layer 3 failover, you might put them in different AZs. If you find that's not something that you really have that ability to do, then you might need to take a look at other solutions. So let's talk a little bit about that VPC router and the route table, right? So I mentioned that there is a VPC router, but you don't have a lot that you can do with it. So the thing you can do is you can view its route table. You can view the VPC route table, and you can edit it, but you can only add static routes effectively. I can't configure BGP or anything else like that. I can't suppress routes. I can't write route filters. If you're used to a Cisco router like I am, this will not feel like a router at all. And so you just need to be aware of that. There are Cisco routers you can put in the cloud. They would not take the place of the VPC router. They might take the place of the VGW, which we'll get to in a slide or two. I want to talk a little bit about route limits, or scalability limits in general. And I have a link at the end of the presentation, but when you're playing around in any of these cloud providers, but I have the most experience in AWS, so I'll talk to that. You need to be very aware of all the scalability limits, for anything that's in that cloud environment effectively. So recently we ran into an issue where there's a maximum of 100 routes in a VPC. And we found out the hard way because we kept going into this routing table and looking at routes, and it was never close to 100. It was always between, say, 2 and 4. And it turns out that 100 is something called the VGW, which we'll talk about in a bit, and the VPC routing table. And by default, even though I can view the routing table, it turns out by default, the only routing table you can view is the VPC router's routing table. So the VGW could have a lot of routes that you can't see, but they count against that 100 limit. And when you hit 101, effectively BGP fails, right? If you only had static routes, it just won't let you put them in. It just blocks you. But assuming that you have BGP, and we'll talk about that with the VGWs, you're going to find that the neighbor relationship fails all of a sudden. You can't, although it's not on by default, you can view the VGW routing table in the VPC routers routing table. You turn on a feature called propagation, and then it will effectively let you see that table. And of course, probably a lot of you are thinking, why would you call it propagation? Because that means something a little bit different to a network engineer. But that's just what they call it. So it's just one of those weird things that you have to be aware of, and I'm just trying to make sure you're aware of it up front. This issue did cost us quite a bit of sleep actually over a few days, so just be aware of that routing limit. Security objects, there's 2 basic VPC level security objects, and that's network ACLs or Acls and security groups, and they are quite different. So the NACL is just like a normal ACL you might write on a router or switch or something like that, right? And it's actually written against the VPC subnet. So you write it against that subnet object that's attached to an AZ, right? The security group behaves a little bit more like a firewall because it's actually stateful, okay? So the ACL, just like a ACL on a router, is not stateful by default anyway. I don't think there's any way it's ever stateful in AWS, but the security group is stateful. The security group is kind of its own object, and so you write the rules within the security group object, and then you can place items inside that security group, and they inherit the policies that are in the security group, right? So they're attached in different ways, and they behave in different ways. However, if you have a networking background, they're not completely unfamiliar because the NACL is just like a NACL you might have on a router, and the security group is not quite the same, but very similar to an access list on a firewall where it's very state aware. So by default, traffic is allowed out of a VPC, but blocked into the VPC unless, I put down here, unless return traffic against a security group, right? So that's because a security group is aware of state. So if I allow it out and I have that object in a security group, it will allow the return traffic back in. right? But the NACL is you'd have to do bidirectional rules. And I was reading a few weeks ago, the way it was explained in the article I was reading, the security group actually evaluates all rules before it makes a decision, whereas the NACL is more like an access list where it evaluates in numerical order and stops after the first match. And so the way it was explained to me, or I was reading it on the security group, you need to be aware that it will evaluate all rules. Now, I think it has logic in there. It doesn't allow you to write a conflicting rule because I don't believe it will allow that. It'll error out. However, it does evaluate all the rules. So you just need to be aware of that on the security group. And remember, an object's placed in a security group, whereas a NACL is written against a subnet. And so we have our VPC, and we set up our subnets. And I put some hosts in each subnet. And the NACL, you can see, kind of sits outside the subnet, and it's written against that subnet object, right? Whereas the security group is an independent object, and I place the end host into the security group. And when I do that, he inherits all the policies in the security group effectively. Inherits probably not the right term, but any object placed in that security group receives those policies. So VGW, I already mentioned VGW in that earlier slide, but a VGW stands for Private Virtual Gateway. And effectively, you could either have, when you're connecting your on-prem environment up to AWS, to your VPC, really is what you're connecting to, you could either do it through a VPN, which is very common, or if you're going to have a lot of traffic going back and forth, or you're going to be doing a large migration or something like that, you may want to get a private circuit. It's called a direct connect. Either one of those, regardless, is going to come into a VGW. Okay, so the VGW is effectively how you're going to connect your on-prem to your VPC, or VPCs, plural, if you have more than one. Now, AWS will refer to your router on-prem, your CPE, as a customer gateway, or CGW. So when you're looking through documents and so forth, anytime they're referring to CGW, you want to think, this is whatever I control. It's my firewall, or that's my router, or whatever, right? So when you connect your CGW up to a VPC, it's pretty much always done through a VGW. Okay. Now you could have someone on the internet that reaches a resource inside a VPC that doesn't go through a VGW, like if I have a web server up there or something. But for actually connecting your on-prem to that VPC, then we're going to go through a VGW. Hopefully that makes sense. If you choose that VPN route, which is, again, very common, most people start with the VPN route when they're working with AWS. One thing that's kind of nice is they will build the VPN configuration for you. So you'll go up into your VPC, and there's some wizards and widgets up there that help you figure out how you're going to build the VPN back. And basically, you're going to define some parameters like your public IPs and so forth. And it allows you to download a template based on your particular gear. So you can say, I've got an ASA firewall that's running 8.2, or I can say I've got an ASA firewall running 9.0. I could say I'm running an iOS XE device. There's other vendors as well. But you'll need to make a few tweaks, but it's actually quite good. You'll be surprised how accurate their template is. They did a good job with it. You'll need to make a few small tweaks probably, and they're very good, particularly on the firewall ones, of explaining if there's a tweak that might need to be made. They do a pretty good job in the comment section saying, the below you only want to implement if such and such requirement is met, or something like that, right? Be aware, if you're going to do VPNs, they do have very aggressive timeout values. So you may want to use something like an IPSLA policy to keep that tunnel up. Or you could do a tunnel with a routing protocol, and the hello packets may keep it up as well. Direct connect circuits are private circuits, so they don't have that same issue. But if you connect your firewall and have it VPN into the VGW, you may want to set up something like an IPSLA so it keeps that tunnel up, because otherwise the timeout values are very aggressive. And then from a routing perspective, the VGW supports BGP and static I believe that's about it for the VGW perspective. So here's what the VGW construct looks like. Very similar. It attaches into the VPC. One thing to be aware of is I think of the VGW as a routing service, not a router, because number one, I can't control it like a router, even if it behaves like one. Number two, it doesn't always behave like a router. And then number three is I think of it as a service because the VGW will actually span your availability zones. Remember, I mentioned to you, this is really just EC2s under the cover. And so it's easy for them to put, an EC2 in this AZ, and an EC2 in this AZ, or a couple of them, or whatever your requirements are. And then typically they build 2 tunnels per VGW, right? So if it's going to a firewall, it's an active and a passive tunnel for HA. If it's going across direct connect, they might be active. Although the VGW, from a routing perspective, it might be active, meaning I have 2 adjacencies. The VGW does not support ECMP, so it will only forward down a single one of those paths. The IGW, or Internet Gateway, what the VGW does for private communication, the IGW does for public communication. So this is how you get to and from the internet from your VPC. So it's very similar in that you attach the IGW into the VPC, and then you, of course, are going to need some kind of a NAT. It's called an elastic IP, and you configure an elastic IP so that you can NAT your items. And there's a couple other ways to do NAT as well. They have a feature called NAT Gateway as well. Just depends a little bit on your particular needs. And then it allows you to get to the internet, or I should say probably the internet backbone, because you might need to get onto Amazon's internet backbone, but not go to the actual internet to get to other resources. For example, if I want to set up a VPN between 2 VPCs, it turns out that's going to happen across their internet backbone. I'm not allowing anyone to go to the internet per se, but I will need a public IP and go out onto the internet backbone to say run route between 2 VPCs in the same region or in different regions, regardless. And so this just looks like this, just like the VGW was down here before. Here you can see the IGW goes over here, and you attach an elastic IP to it, and it does effectively a 1-for-1 NAT. If you have an elastic IP, you can use a NAT gateway if you want to do a NAT overload or something like that. And which way you want to go really depends on what problem you're kind of trying to solve. So let's take a real quick look at what this all looks like when we put it together. So we create our VPC, we set up our subnets across the different AZs, puts in the VPC routing table. I connect a VGW, that goes back to my on-prem. I connect my IGW, give it an elastic IP, and I can get to the internet. One thing to be aware of, not all of this is required. This is just to show you some of the different objects and items, and there's a lot more that we could go into. You could really do a week-long course just on this. However, for example, if you do not want your VPCs to get to the internet, don't put in the IGWs, right? Just force default to come back through the VGW to your on-prem and let it go to the internet in that regard. So you do have options, right? You typically want the VGW. You have no say in the VPC router. That's going to be there whether you want it to be or not. However, you can program static routes into the VPC router. For example, I could take a quad 0 route and point it to my VGW, and then I wouldn't necessarily use this. I could take a quad 0 and point it to my VGW, and then point to 8.8.8.8 and point it to my IGW if I just wanted to go to Google for DNS, for example. So it's just to kind of get you a feel for what some of the different options are. Oops, and I guess I forgot, we also have a host in there with a security group. So real quick, just some tips and tricks and thoughts, right? Be aware that when you're going to connect to resources outside of your VPC, you will probably need an IGW because you're going to have to go on the internet backbone. May not need to go to the internet proper, but you may need a public IP. Just again, remember you need to consider carefully how you're going to do HA in the cloud, right? Are you going to do it through AZs or through some other method? And just a word of warning, IGWs and VGWs, they look like routers, but you might want to think of them as routing services because they won't behave in the same way that a Cisco router behaves, right? I mean, what router would lock its table and tear down its BGP after 100 routes, right? So again, be very aware of the scalability limits in AWS, right? Remember that while many of these network services might look like they're actual appliances, they're not. They're an EC2 under the hood most times. And so you need to kind of consider that when you're coming in. So that's really it. So real quick, I'll just talk about these links a little bit. I have a link up there to a company that does specific AWS training. It is a fee-based company, but it's very reasonable and they do a very good job. But no matter what, if you're interested in this, they have a free course. It's about 12 hours long, and it does what I did, but across 12 hours. So you get a lot more detail. It's very good. I have a link to those VPC scalability limits because again, those can cost you an awful lot of research time. So you want to research those limits up front, not on the back end if you can avoid it. And then I have a link to two of my favorite talks from last year's reInvent. That is AWS's big conference that they do every year. One of them is on VPCs and how to connect different VPC designs together. And the other one actually is very interesting. It does go pretty deep into the weeds, but it's about infrastructure in AWS and how they approach infrastructure. So those are the links, and those will be included in the slides when we get them posted.
All right, we do have a question that came in, Jason, during that. If you don't define an IGW, what is the default path?
Right, so that's a good question. Effectively, if I don't have an IGW, I need to program into the VPC router a default router, a quad 0, right? And typically, if I don't have an IGW, I'm gonna program that default to point to the VGW, so it comes back to my on-prem for default. Good question. Thank you.
Great, and that's Chief. That seems to wrap up all the questions. You must have done a great job on all the clarification of all the items there. Just a reminder for everyone, we will have this presentation posted up on the LA Networks website. I would check near the end of the week or early part of next week. And we'll have, as part of our monthly newsletter, a replay of this available. But if you check our website, say Monday or Tuesday next week at the latest, we'll have this posted up there for your replay, and we'll actually have it up on YouTube as well in the very quick, very near future, and also up on our social media channels, Twitter, Facebook, and LinkedIn. Jason, thanks for the great informative information presented this afternoon. We look forward to seeing it all up on our up at Cisco Live again, coming up on June the 12th. We do have one comment, Jason, just kind of came in before we wrap up. Is it possible to post the links in the chat window so somebody can see them up on there?
I'll be on the website by, like he said, by next week at the latest. So
yeah, and Alex, who wants to get the and also the links, just shoot an email over to marketing@la-networks.com, and we'll get that forwarded over to the right resources internally to get that information over to. So that's marketing@la-networks.com.
Yeah, that would work great as well.
Okay, perfect. Jason, again, thanks again. We'll see you coming up in a couple weeks at Cisco Live. As always, great information today.
Yeah, thanks everyone. I appreciate your time again.
Thanks everyone.